All right, thank you so much for joining us today. In this video, we are going to talk about cross or vector product. Now, remember we talked about dot product and we said that with dot product, when we dot two vectors, we are going to get a scalar. That's the reason why we talked about scalar or dot product. So when you hear dot product, when you dot two vectors, you are going to get a scalar. But in this video, we are going to look at when we cross two vectors, we are going to have a vector again. So that's what we are going to do here. Here, the order is very important. Unlike the dot product that we can just dot a dot b, which is the same as b dot a. But here, the order is very, very important. So now let's start with something. So when talking about, let's say vector a, so let's assume that we have vector a and b, right? And we want to do the cross, then we are talking about a cross b. So that's what we mean by cross product, right? And then the magnitude of this, which we will learn it very soon, the magnitude of a cross b is the same as magnitude of a, magnitude of b sine theta. So let's compare this one with dot product. We saw that a dot b was equal to magnitude of a, magnitude of b cos theta. So, kind of look at the relationship with what we're having with the dot product. Now we saw that anytime a and b are perpendicular, then we are going to get 0 because cos 90 is going to give us 0. But here, whenever the angle is perpendicular to each other, that is a is perpendicular to b, we are not going to get it to be 0 because sine 90 is not 0. But we saw that when the angle here is parallel to each other, we are not going to get 0 here. But here, when they are parallel to each other, because it is sine, we are going to get it to be what? 0. So this is kind of like some stuff that we need to figure it out. So I'll write it for you. So what we are going to do is, we are saying that if, let's assume that if a is equal to b, so if a is the same as b, or let's say that a is parallel to b, then what we are going to see here is then sine theta will be equal to 0 because they are parallel to each other or they are on the same path. So it means that the a cross b is going to give us 0. So that's one thing that you need to know and cross product. So with the dot product, that is when it is perpendicular. When it is perpendicular, then a dot b is equal to 0 because if it is perpendicular to each other, then cos theta is equal to 0. So that is one thing that you need to learn from here. So with cross product, we need to learn this. We need to learn this here. And then also we need to learn that when a is the same as b and or a is parallel to, let's say, b, then sine of theta will be 0 and a cross b is going to give us 0. Now note that, as I said earlier, the order is important. Order is important. I will show you something right now. So the order is very important. Now remember, as I said, a dot b is the same as a dot b dot a, but here a cross b is not the same as b cross a. That is the reason why we are saying that the order is very, very important here. So before we just dive in, let's look at some properties, right, of cross product that are valid, and then based on that we can now solve more examples. So first property that I will talk about is, as I said, the order is important. A cross b is not the same as b cross a, but rather minus b cross a. Good. That's one thing that you just need to have it off head, right? And then if I have something like a cross b plus c, right? This is the same as a cross b plus A cross C, which is like kind of distributive property here. Now let's assume that we have a scalar. If we have a scalar like m, which is multiplying this, then this will be the same as, I can decide to multiply the scalar to A before I do the cross, or I can decide to multiply the scalar to B before I do the cross, or I can do the cross A and B before I multiply it by scalar. So they are all the same, but what you need to know is m is a scalar. Yeah, a scalar means that it's kind of be like 2, 1, any of them. Now, let's look at something and then we write this. Remember that we saw from dot product that I dot I is equal to 1, right? And it's the same as J dot J, which is the same as K dot K, right? They are all equal to 1. And we saw that when we dot any other direction, like I to K, and then let's say J to K, this gives us 0 with dot. Now let's see what is going to happen when we are talking about cross. So here you need to pay attention to how we are changing things with dot and cross product. So let's see that. Now what is J cross I cross I? And then let me say, yeah, let me put it there, and then J cross J, and then K cross K. If this one was dot product, we are going to say that it's equal to 1. But this is cross. So this is going to be 0, this is going to be 0, this is going to be 0. Why? Because this is, they are on the same line. They are the same. So as I said from this, that whenever A is the same as B, then it means that we are going to, if A is the same as B, then this is going to be something like A cross A, which is equal to 0 from here, right? Because they are parallel to each other. So that is the idea. How did I see that? Now, if I have my, let me say just X and Y coordinate, this is I direction. And then I direction is having an angle of 0, right? So this is going to be, let's use the formula that we just learned. I dot I, oops, I cross I is equal to the magnitude of I, right? And then the magnitude of I sine, the angle here is 0. But we know that sine 0 is equal to 0. So everything here goes to 0, and then we have it there. So that is basically what we are just doing here. So anytime we are dealing with cross, when you cross a vector to itself, you get to 0. So that's one thing that we need to learn here. So let me just combine them together. So I cross I is the same as J cross J is the same as K cross K, and this should give us 0. Simple. Now let's look at I cross J. We are moving to different direction. So different direction here is kind of angle of 90, right? Because if I have I here and J here, the angle between them is 90, right? So let's use the formula that we just learned here and see what we are going to get, like this one. So this is going to be magnitude of I, magnitude of J, sine 90, right? But don't forget, we know that I is the same as, if we are in the 3 dimension, let's go in 3 dimension. This is 1, 0, 0, and J is 0, 1, 0, right? So if I've not watched the previous video, I think it's best for you to go there to go and watch so that you understand what we are just doing better. Good. So you see that this is what we are having here. So we said that this is a unit vector. I mean, the magnitude is 1, right? So the magnitude of I, when I find the magnitude of I, this is 1. Magnitude of J is also equal to 1, right? So this is kind of 1 times 1. Then what is sine 90? Sine 90 is 1. So this is going to give us 1. So it means that I cross J in different direction, rather giving us 1. Do you get it? It's giving us 1. But let's do something basic here. Like let's do something that is going to help us to see what we are going to do. Because basically, if I do this, remember we are in 3 dimensions, we are not in 2 dimensions, right? So when I do this and I'm picking this one to be 1, this one to be 1, and this one to be 90, I'm going to get 1. But when I cross this and this, I'm not going to get 1 from what I'm getting from the function here. But what happens when I do that? Now, what you need to know is this one, when I cross 1, sorry, when I cross I and j, I'm going to have k. So when I cross different direction, I get other direction. But remember, the order is important. So how are we doing this? We are doing this in right hand form. So let me pick my j, let me pick my j, and let me pick my k. So it goes like this. I to j is going to give us the k, right? And then j to k is going to give us the I. And then the I to k to I is going to give us the, which one is missing? J. Good. So let's go right hand. So it means that I cross J is going to give us K. J cross K is going to give us I. So J cross K is going to give us I. And then K cross I is going to give us J. So this is going to give us J. So K cross I is going to give us I, right? A is going to give us J. Oh yeah, J is right. So that's J. Good. So basically, we need to note something here. The order is important. Let me move in different direction. I want to move in this direction, and this direction. So when I do that, it means that I'm actually moving from I to K, not K to I, right? So it means that I'm going to have something like this. Let me just shift this once more. I'm from here. Now I'm moving from I to K, right? When I'm moving from I to K, I get negative of this. So that's what is going to happen here. So I'm going to have negative J. As we saw from here that one of them should be negative. So when you want to go in the other way, you should be getting negative. Then guess what? What will happen here? When I reverse K and J, so I'm now moving from K to J, right? So from K to J is going to give us minus I. And then from J to I is going to give us negative K. Very simple. Very simple from there. Is that right? So basically, if we're able to picture this graph here, or this right hand rotation here, right, it will help you to always bring out this kind of things, like when you are doing them. Very nice for you to picture that. It's very simple. We will do some proof on that and you better understand. But don't forget, when you see I is 1, 0, 0 in 3 dimension, J is equal to 0, 1, 0, and then K is equal to 0, 0, 1, right? So if you have not watched the previous video, please go and check it. Let's look at A. Let's look at A. E is, we are talking about, let's assume that A is equal to a1i plus a2j plus a3k, right? So this is a vector, right? Let's assume that B is b1i plus b2j plus b3k. Then the question is, what is A cross B? We are come to learn something, right? So we actually saw that A times A cross B is this. It's not times, it's cross. A cross B is the same as this, but we want to move in different way so that we can solve them. So anytime we have A cross B, we have I, J, K, the directions, right? We need to have all the direction on the first row. The second row should be the first vector, and then the last row should be the second vector. So the first vector is a1, A2, A3. And then the second vector is B1, B2, B3. So it means that here we should be able to know how to find the determinant. So this one that you are seeing here is the determinant. We are trying to find the determinant of that, right? So basically that's what we are going to do from here. So we should be able to find the determinant of this graph. We know how to do determinant, right? Yeah. So this is what we are going to get from when you cross two vectors. Ij is fixed on the top, and then your first vector will come here, second vector to come here from this. Without the ijk out. So if you have not forgotten this, you remember this one goes with a cofactor plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is what you are going to go with it, right? So if I want to do this, then if I maintain I, so I, the position of I is positive. So I cancel this, and I'm going to have A2, B3 minus A3, B2, right? So when I cancel this and this, I multiply this one by this, I have it here. Then I multiply this one by this, I have it here. Then when I move to this, this is minus, so I'm going to have minus j, open bracket. So now this out, so to be left with a1 times b3. So a1 times b3, and then when I cross it, and then a3 times b1 minus a3 times b1 plus k, because this is positive. And when I cancel this guy and this guy, a1 times b2, so a1 times b2 minus, definitely this one will be a2 b1. Good. So this will be the determinant when you will just want to solve. And you see that at the end of the day, this is going to give you a scalar, this is going to give you a scalar, this is going to give you a scalar. And we have k, j, I, which is going to form a vector. That's why we call it a vector product. Because at the end of the day, when we do the cross, we get a vector out of that. Good. Very good. Now, before we take example, I think I need to add something small to it, and then we take our nice examples, right? So let me just try and move this people up small so that I can have space to write 2 or 3 things, and then we are done with this one. So we are going to have, let me just shape this guy up here, and then my covectors are over here, and move this guy somewhere here. Good. Okay, that's okay. So now, few things that we need to learn is the magnitude of A cross B. When you find the magnitude, like example, when you are done finding A cross B, like this one, like this is A cross B. When we are done and we find the magnitude, it means like this is going to be a vector, right? So now we know how to find the magnitude of vector from the previous videos. So the magnitude of the cross of A and B is actually the area of a parallelogram. It's very important. It's the area of a parallelogram, right? And then when I need the area of a triangle, if I need area of a triangle, I don't need to do much hard work. All I just need to do is pick half of what the area of a parallelogram, and then I'm done. Good. So when I'm done finding the area of a parallelogram, and I just pick half of that. So it's kind of, we are saying that if I have a parallelogram of this form, this is not nice, of this form, then when I divide it into two, I'll have triangle. So 2 of them. So I pick this one second, right? And this, and then we have the area of triangle. So that is what you are going to get. And then last thing to note, which I'm going to use red to write it here, is A cross B is perpendicular, right? perpendicular to A and B. Very, very important. So anytime we talk about A cross B is perpendicular, we want to find the perpendicular. It's good for you to just go for the cross. And then when you get the cross, you get a vector, and then you are done. So let me just do quick recap here before we start the examples. What we just need to know is, now we know that when we cross two vectors, we get a vector, right? And this is the formula that we need. And then we also saw that when two vectors are parallel to each other, then when we cross them, we need to get 0. So this one will talk about collinear, right? When you talk about something is collinear to each other, or coplanar. We saw from coplanar that when two vectors are parallel and then they are collinear, I say collinear, they are coplanar, right? Good. So it means that here, if the question is also talking about A and B are collinear, then we can use the cross product to do that. So some of the terms, I'll compile all of them, and then maybe I'll give it to you in the next video, like terms and which things, like either we are going to use the dot product or the cross product. Good. So these are the things that we need to know. Please master this here. This right hand and left hand diagram. Master it. So this is, let me just put it there. This is going to be minus j with the green, and this will be minus I, and this will be minus k. So the red is with the red and the green is with the green. So that's what we just need to do. Let's take an example and then we'll be fine. So first we want to show that I cross j is equal to k. So we just saw from left, right, and we saw that, okay, it's going to be k. But let's work with it and see. So basically we want to prove this. So prove. So we know that I is equal to 1, 0, 0, right? And we know that j is equal to 0, 1, 0, right? So we are just going to use a theorem that we learned here, this one, right? That's what we are going to use. So we know that if I want to cross I and j, I cross j, this should be equal to, first I need to have I, j, k on the top, because I need to have 3 by 3 matrix. Now what is this? This is the first vector here, and this is the last vector here. So what's the first vector? We have this here. So we are going to have 1, 0, 0, and then j is 0, 1, 0. Don't forget, always when you are doing the determinant here, plus, minus, plus, minus, plus, minus, plus, minus, plus. Good. So let's just go through and see what we are going to get. So when I maintain I, I cancel this, I cancel this. 0 times 0 will be 0. 1 times 0 will be 0. So I'm going to have 0 minus 0. Minus j, because this is minus. When I cancel this and I cancel this, 1 times 0 will be 0. 0 times 0, 2 will be 0. So I'm going to have 0 minus 0 plus k, because this is a k and this is positive. So when I cancel this, I have 1 times 1, which is going to give us 1. And then when you cancel 0 times 0, which is going to give us 0. So basically, this is going to be 0i minus 0j plus k. 0i is 0, 0j is also 0. So this is going to give us a k. So that's what we are going to get. So we can use this to prove all of this. All of this here. We can use that to prove all of them, to see that this is k, this is j, this is I, in that order. Good. So basically, that's what we just need to do here. But what we just need to know is, we know this and we know how to write this form very nicely from there. All right, let's take some examples. Now, if A is this and B is this, determine A cross B. So we know we want to find A cross B. So what we just learned is what we are using. So A cross B is equal to, we use the I we use the I, J, and K. Now this should be the A, and the last one should be the B. So these are the A. We don't go with the I, J, K. We just use the coefficient. So this is going to be 8 minus 6 and 4. And the B is 7 minus 11 and 9. So that's what basically we are going to get from doing this. Let's try and multiply by finding the determinant. So when I maintain I, okay, let me just do something like this so that since we are taking first example, we can see it. So when I cancel I out, it will be left with this, right? So I'm going to have minus 6, 4, minus 11, 9, minus J. Don't forget we are using the cofactors, plus, minus, plus, plus, no, minus, plus, minus, plus, minus, plus. So always the J is minus. If we are using the first row, always J is minus. When I cancel J, what am I going to have? 8, 4, 7, 9. So when I cancel J out, 8, 4, 7, 9. Then plus K. When I cancel K, what am I going to get? 8 minus 6, 8 minus 6, 7 minus 11. So we just finish it up. So now this is 2 by 2 matrix, which we are finding the determinant. So I just multiply this by this and this by that. So what is minus 6 times 9? That one should give us 54. So minus 54. Then minus 11 times 4 is going to give us minus 44. Minus J, open bracket. 9 times 8 should be 72. Minus 7 times 4 should give us 28. Plus K. Then 11 times 8 minus 11. So minus 8, 8. Minus 6 times 7 should be, I think, minus 42. So yeah, I think so. So that's what we are going to get. Let's try and simplify that. So we are going to have I minus 54 plus 44 minus J. I think we can do the subtraction for this one. And this is going to be 44. And then plus K minus 88 plus 42. So finally, this is going to give us, when I add this one together, I'm going to have minus 10 minus 10I minus 44J. And then when I add this one, I'm going to have, I think, 46. Yeah, so minus 46K. So this is A cross B. So that's what the question was asking us for, A cross B. So now that we are done finding A cross B, we want to find the area of a parallelogram with the side A and B. So we know the formula, right? The formula for area of a parallelogram is just the magnitude of A cross B. That's all. So let's find the magnitude of this and then we are done. So what will be the magnitude? So the magnitude is just pick the coefficient of I, square it, pick coefficient of this, square it, pick coefficient of that and square it. Then you are done. So minus 10 squared plus minus 4 squared minus, no, plus 4 minus 6 squared. So basically that's all, and then we are done. So what is 10 squared? This should give us 100 plus 44 squared should give us 1936, and then 46 squared should give us 2116. Add everything and we should get something like 4152, and then in decimal places we are going to have 64.44 square units. So I love vector algebra so much because kind of some of the questions are very straightforward, like kind of very straight for us to just do it and then get everything right. right? But sometimes it gets too hard, but we will be fine. So this helps us to find A cross B and then the area of a parallelogram, right? So we are done with question 2. Let's look at what is also in stock for us again. Find the area of a triangle with the sizes this, this, and that. So remember the area of a triangle, right? Half of the area of what? A parallelogram. But anytime you have three vertices, what we just need to do is we need to find A cross AB and AC. That's what you need to know. So this is kind of like we want to find, this is ABC. So for us to find the area of this triangle, we need the vector of AB and AC. Sorry, so AB and AC, not AB, BC. No, we need AB, AC. So that's what we need. So we need vector AB, vector AC. So we learned that vector AB should be the position vector, which is B, minus the position vector A. So B minus A. And this is going to be the position vector C minus the position vector A, right? So always C comes before the A, the first one. So what is the position vector of B? Or let me say, what's the position vector of A, B, and C? So position vector of A, position vector of B, and C. So position vector of A is 2I minus 3J plus K. And then for B will be I minus J plus 2K. And then minus 2I plus 2J plus 3K. So this is the position vector. If we are saying that position vector, this is what we mean. So now let's try and find this. So B is I minus J plus 2K minus A is 2I minus 3J plus K. Let's try and multiply through by minus and then work with the function. So I minus J plus 2K minus 2I plus 3J minus K. So what are we going to get from here? Go with the same direction. This and this is going to give us minus I, right? Going to give us minus I. And then this and that is going to give us plus 2J and then plus K from here. So we can basically write this one to as minus 1, 2, and 1. So that is vector AB. Now vector AC is going to be minus 2J plus 2 minus 2I plus 2J plus 3K minus A again. So 2I minus 3J plus K. Simplify this, we have minus 2I plus 2J plus 3K minus 2I plus 3J minus K. So what are we going to get at the end? We have I, so this is going to give us 4, right? What's C? Yeah, it should give us 4. Oops, I think point coordinate error or something like that. So I think my coordinate here should be 1. Yeah. So let's make this one 1 so that this one will be just I. Good. So if that's the case, I'll have this one to be I. Good. Is there anything that we need to change again? No. So this one should be the 1. So negative 1 here. And then this one will be that. So let's now do it. So this is going to give us negative 3I plus 5J plus 2K. So we are just adding this to this, and then J to J, and then K to K. So this is going to basically give us minus 3, 5, and 2. Good. So now that we know that we have now two vectors, then what will be the area? So area of a triangle is equal to 1/2 of the area of what? A parallelogram, which is AB cross AC. So here what we just now need to do is let's find the area of a parallelogram and just take half of that and we are done. So now let's go. So let's pick A. Let us pick A cross B and do that. AB cross AC. This is going to be IJK. So when you solve more examples, you become very good with this and then you just be doing them. So -1, 2, 1, and then -3, 5, 2. So I'm using this coordinate here, which is AB, right? So AB is -1, 2, 1, and then AC is -2, 5, and 2, which I have them here. So let's try and solve. I'm going to have I. Then when I cancel this and this, it will be left with 2, 1, 5, 2. I said always, if we're using the first row, always J is negative. So J, cancel this. This will be -1, 1, -3, and 2. Plus K, what will be for K? Cancel this, -1, 2, -3, 5. Good. So I, and this is going to be this times this, and then this times that. So we are going to have 4 minus 5 minus J minus 2 plus 3 plus K minus 5 plus 6. So I will explain. So I multiply this by this, 4 minus this times this, with 5. This times, no, this times this is -2 minus this times this, which is minus, will become positive. Then this times this will be -5 minus, but we have -6 will become positive here. So we are going to have -I minus J plus K. Interesting. So this is what we are going to get. And we can also write this one in the coordinates form -1, -1, and 1. So all we need to do is now we just need to just find the magnitude of AB cross AC, which is going to be just picking this one and just taking the square root. So this is going to be -1 squared plus -1 squared plus 1 squared, which is 1 plus 1 plus 1, and this is going to be root of 3. So that's all. So let's just put it here, and this is going to be 1/2 square root of 3, square it, because we are talking about area. Good. So it's very simple. Just I'm going to give you trial questions that you are going to try your hands on. So it's kind of very simple. All you just need to know is just memorize, like know the formulas, work more example with them, and you're just going to remember them and then just do them. Right. So I have this trial question here, right? So the same question that we did, but this one I've done it, 3 of them. So show that this is equal to I, and then this is minus J, and this is minus K, as I did similar one here in the video here, right? Good. And then now if A is this and B is this, determine A cross B and find the area of parallelogram. So the same thing like example 2, and then find the area of a triangle, the same thing like the example that we just did. And then I'll just talk on question 4 and 5, right? So you see, we made some note that when you see A cross B is perpendicular to A and B, right? So here, this question here, Find a vector perpendicular to the plane that passes through the point this, this, and that. So all we need to do in question 4, I'm just going to guide you, then you just do the rest. All you just need to do in question 4 is to find vector AB and vector AC, right? And then cross vector AB to vector AC. So that will be the vector perpendicular, right? That's what you're going to get from this, right? And this is like kind of the normal vector, right? When you pick this one, we can call it the normal vector. So that's what you just need to do here. And then when you are done, since you want to find the area of the triangle, you just find the magnitude as we just learned from here. So area of a triangle, I will need the answer in the comment section. That's why I'm guiding you. So this A cross B cross A, C, half of that. So when you are done finding the vector perpendicular, which is this, then you find the magnitude and you take half. Put your final results in the comment section. I think we cannot put A there, question 1 there, but we can put B, question 2, question 3, question 4, and question 5 there. We can put it there. So please put it there so that we can see. So I'm just going to do question 5 for you here. So do question 1, but you cannot put the result there because we have it's like kind of proof. And then do question 2, 3, and 4 and leave your final results in the comment section. Let me do question 5. Right. So question 5 is easy. Same thing, same idea. So here what I'm going to do is I want a unit vector perpendicular to this and that. So as we are talking about perpendicular, let's assume that the vector perpendicular, so we need to talk about this one first. So let me assume that that is n, right? So I'm going to have n to be equal to A cross B, right? So let's do that. This is going to be I, J, K, and this is going to give us 2, minus 6, and minus 3. And then B is 4, 3, and minus 1. So let's go through quick. This is going to be I, cancel this, minus 6, minus 3, 3 minus 1, right? And then minus J, 2 minus 3, 4 minus 1, because we are going to cancel this and that, which is right. And then plus K, we cancel this and that, so we have 2 minus 6, 4, and 3. Indeed. Let's try and finish it up. So this is going to be I, 6 plus 9 minus J minus 2 plus 12 plus K, 6 plus 24. So multiply this one by this, which will be positive, and then minus, but 3 times minus 2 will be minus 9, giving us positive. This times this will be minus, this and this will be minus 12, minus minus will be positive. This and this will be 6. 6 times 4 is 24, minus minus will give us positive. So we are going to have 15I minus 10J and then plus 30K. So we're able to find this. Now we need the unit vector perpendicular, right? So remember we need vector, right? So we need vector, let me just do it, n cap is equal to the vector itself. So if I'm calling this one like vector n, which is this one, so this is a vector. This is equal to vector n divided by the magnitude of the vector n. So that's what we just need to do. We need vector, right? So that's all we need to do from here. So all that we need here is we just need to find the magnitude, which is going to be 15 squared minus, no, plus 10 minus 10 squared plus 30 squared. So I'm not using calculator, so just simplify this. I want you to put the final results in the comment section for this. So simplify this, what you are going to get, and then you're just going to have something like 15i minus 10j plus 30k divided by the results that you're going to get here, right? Then you put it here. So if this is going to give us A should be here, and put the final results in the comment section. Yeah. So please, the try questions that I'm giving you, please try your hands on it and put it in the comment section for me to see if we are doing them right. I think the other videos, I'm not seeing the trial questions that um, I'm giving to you guys. So if you guys are not doing the trial questions, then I can just leave them out. All right. See you in the next video.